my friends, we'll be talking about water analysis. First, let me bring you to the basic. Water, our daily basic needs for shower, dehydrate, and other things. Water consists of hydrogen and oxygen, or we can conclude as H2O. The best part is, water covers more than 2/3 of this planet. As we know, the sea and glaciers. There are different types of water due to different kind of surroundings such as lake, pond and river. Water also regulates the earth's temperature that makes them more important in the human's life. Lastly, a new fact we all need to know about water is trillion tons of water evaporated every day. Now, let's hear what others will talk about.
Analytical chemistry plays an important role in inorganic chemistry for several reasons. First, identification and quantification. Analytical techniques allow chemists to identify the element and compound present in a sample and determine the concentration for understanding the composition of inorganic materials. Measuring the purity of inorganic compound is vital in both research and industrial application. Analytical chemistry provides the method to detect and quantify impurities, ensuring the quality of products. During inorganic reaction, analytical method can be used to monitor the progress and identify intermediate species. This helps in optimizing reaction conditions and understanding the reaction mechanism. Next, analytical chemistry is also used to detect inorganic pollutants in the environment and ensuring environment protection. It also helps in assessing the safety of materials and processes in various industries. In the development of new inorganic materials such as catalysts, semiconductor, and nanomaterials, analytical techniques are important for characterizing their composition, structure, and properties. Overall, the integration of analytical chemistry in inorganic chemistry enhances the ability to study, develop, and apply inorganic compounds effectively.
Hello, my name is SITI ANISSA, and now I will talk about the qualitative and quantitative analysis. First, qualitative analysis is a process used to determine and identify the chemical properties of an unknown substance. There are a few examples of process to determine the unknown substance in water using qualitative analysis. The first one is the color is measured by comparison of different samples visually or with a spectrometer. This is a device that measures light transmission in a substance in order to calculate the concentration of certain contaminants. When the water has an unusual color, this is usually does not mean a health concern to a person. Second, the suspended matter in the water absorbs light and causing the water to have a cloudy appearance. This is called turbidity. Turbidity can be measured with several techniques that show the resistance to light transmission of the water. This is the image shows the curve of absorbance in water analysis that we do the experiments in order to determine the force fit is the quantitative analysis. In the branch of analytical chemistry known as quantitative analysis is concerned with figuring out the quantity of an unknown substance. It contrasts with the qualitative analysis. Other than process that we know in the qualitative analysis, quantitative analysis also can determine the water quality by assess the number of quantitative laboratory analysis such as pH, total solids, and conductivity microbial contamination. The pH is the value that determines if a substance is acid, neutral, or basic. They calculated from the number of hydrogen ions that present in the water analysis. This is the example of quantitative analysis.
I will explain some of the techniques used in this analytical chemistry. Firstly, gravimetry analysis is a fundamental method that involves measuring the mass of a substance to determine its concentration or composition. In this process, the analyte is converted into an insoluble and pure compound of known composition, which is then isolated and weighed. There are two main types of gravimetry analysis, which are precipitation gravimetry and volatilization gravimetry. Furthermore, gravimetry is also used in environmental analysis, which is to determine the concentration of pollutants such as sulfate and phosphate in water sample. Next is spectroscopy, which divided to some types. First is inductively coupled plasma-based spectrometry. This technique is highly sensitive and can detect trace elements and heavy metals in water such as lead, arsenic, and mercury. It measures the mass-to-charge ratio of iron to identify and quantify elements. Besides its atomic absorption spectroscopy can measure the concentration of metal in water by analyzing the light absorbed by atom in the vapor phase. It is widely used for detecting metals like copper, zinc, and iron. And the other is inductively coupled plasma optical emission spectroscopy, which is similar to the first one. This technique uses plasma to excise atom and ion. The AHMAD light at specific wavelengths is measured to determine the concentration of the element in water, useful for analyzing multiple elements simultaneously. Titration is one of the techniques when a solution of known concentration is used to determine the concentration of an unknown solution. It involves adding a titrant to a solution until a reaction is complete, as indicated by a color change or an analytical measurement. The volume of titrant used allows for the determination of the analyte concentration. This technique is widely used in laboratories for acid-base, redox, and complexometric titration. Moreover, this technique also used for water analysis.
Hi, I am ATHIRAH. So now I will talk about in real life example. A practical application of inorganic analytical chemistry is water quality analysis. The techniques such as ICP, OES, and AAS are used to detect and quantify the metal ions and contaminants in water sample. Plus, it's also to ensure the safety of the water drink and also for the environmental protection. For the sampling method, we use the reagent bottle for both sample of lake water and pond water to collect it directly from the lake and the pond. Next, sample preparation. First, for the equipment and the container, we use a clean, sterile, and appropriate container, which is a glass reagent bottle for each sample of lake water and pond water for sample collection. Second, filtration. Filtration of the sample is used to remove the suspended solid. Third, digestion. The sample is being digested by using the acid digestion to break down the complex matrix by the metal analysis. Or dilution. The sample was diluted to bring it to the analyte concentration within the detectable range. So, for the result, as you can see, for both samples, we use 3 trial times. Well, based on the data received, we could say that the average amount of volume used for pond water is 3.86 and the average volume used for lake water was 3.36.
So, as stated by my group members, now we all could gain a new knowledge about this topic. First, this topic could show us how to identify the presence of organic compounds and microorganisms contained in the water sources, and also to identify any potential contaminant. This step is vital because the use of water in our daily needs, such as for drinking, we would not want a contaminated water to get into our body. It could cause so many unwanted diseases. That is why we should be able to know if the water we had is suitable for daily necessities or not. Those microorganisms are very dangerous, especially for humans' health. And lastly, this topic could help us to understand the biological impact of water in living organisms and ecosystem, as were mentioned earlier, the impact to our health and other organisms.